So, it's working, right? Perfect. Okay, new topic today, guys and girls. First of all, I'm going to say hello to everyone. Second, we're going... Whoa, something changed here. Give me a second, guys. Yeah, here's YouTube, right? Ah, yeah, here you can see it. And I need chat on the other side. Yeah, that's way better. So, okay, browser's not working. Maybe I have to reopen and open the browser here then. Let me see. Let me fix it. So, tutorial. Here. Should we redo the topic from last time? We want to redo like R values, L values. Maybe we should do it again because there was some confusing stuff last time. I think it's really good for the topic what I did last time, the unary thing, right? Was it unary overloading? It was, right? Wait, we're gonna check it together. So open up here this so you can see it, right? Here we go. Scrolling down the C++ road. So we did like overloading unary operators plus minus and the not operator here, overloading comparison to operators. Subscript operator. Oh my god, so much. Okay, we're going to R values and L values again. Quick, right? Quick. R and L values. R and L values are value. I want to redo it quick, right? Come on. Should go faster. So R value references. Is it R value reference? Actually, I want to have L values and R values. That's what I want to have, right? Wait, is this stream working? Yeah, it is. Perfect. Wait, the YouTube stream is also working. Why I'm getting no data? No, everything should work, right? Give me a second to check it out. No, everything is fine. Okay, now it's working. So back to topic, value categories, L values and R values. Let's redo this quick. Before we talk about our first compound type L value reference, we're going to take a little detour. Is it detour? Detour? Is it a detour talk? What does this even mean? So now I need my favorite website, leo.org.
Detour.
Detour. Okay, good to know. Detour. So, and talk about what an L value is. In lesson 1.10, Introduction to Expressions, we defined an expression as a combination of literal variables, operators, and function calls that can be executed to produce a singular value. Okay, let's see. Oh, this is nice. I like it if it's basic like this, you know. We have our integer main. Yeah, and we have this one, blah, blah, blah. The expression 2 plus 3 produced the value 5. Correct. Yeah. Because of, yeah, okay. In the above program, the expression 2 plus 3 is evaluated to produce the value 5, which is then printed to the console. In lesson 6.4, increment, decrement operator side effects, we also noted that the expression can produce side effects that outlive the expressions. That's why we like C++, by the way. That's the reason, right? So we have integer x, and then this is like gonna initialize x with 5, right? With a double. No, it's just an integer. So then we have this expression. This expression statement has the side effect of incrementing x. Yeah, true. So if we say std out x, then we're getting 6. Yeah, that makes sense. And then we return 0. That's good practice to do it this way, right? The other way can be dangerous. This way is actually better if you want to count something up or something like this, right? In the above program, the expression plus plus x increments the value of x and the value remains changed even after the expression has finished evaluating. Besides producing values and side effects, expression can do one more thing. They can evaluate the object or functions. We will explore this point further in just a moment. The properties of an expression. To help determine how expressions should evaluate where they can be used, all expressions in C++ have two properties. Okay, what does property mean again? Let's do this quick. Property. Okay. A type and value category. The type of an expression. So all expressions in C++ have. Do you know what I really like in C++? If you keep learning more and more and coming back to a topic later, it's sometimes interesting. I think it's a good thing to do because you're getting a better understanding, right? Because you have more knowledge, and if you're reading text again, maybe you're gonna finding something to think about what you just overjumped for a second, before. The type of an expression. The type of an expression is equivalent. I'm going to read this quick again. Expressions must have two properties. All expression. What is expression then even? Sometimes it's good to read like sentence. Carefully. A type and a value. Okay, that makes sense. That's our. Okay. Got it, boys. And girls. The type of expression. The type of an expression is equivalent. I'm not pronouncing this word correctly, guys.
Equivalent,
right? Equivalent to the type of the value, object or function that results from the evaluated expression. For example, okay, we have this one. We have auto, right? Then we know this. Okay. This is defined this way, right? We will end up to have. Okay, we want to have a 3, so it will be an integer, right? And if this is an integer, this will be also an integer. Yeah, okay, got it. And here we have a double, and then it's defined this way, and we will have a double, and that will be also the double, right? So okay. Easy. Then we have for V1, the compiler will determine at the compile time that a division with 2 integer operands will produce an integer result. So integer is the type of expression. Via type inference, integer will then be used as a type of V1. Yeah, it's easy. For my current state, right? I think it's not fair to say it's easy, right? You have to say it's easy for my current state of my C++ learning journey. So in the beginning it was also like not easy. I have a huge discussion about this topic, and even this one, right? Really interesting. The compiler will determine at compile time that a division with a double operand and an integer operand will produce a double result. Result. Is it result or result? It's result, right?
Result.
Okay, it's not result. Okay, result. Remember that arithmetic operators must have operands of matching types. So in this case, the integer operand gets converted to a double, and the floating point division is performed. So double is the type of this expression. If you're not sure what is going to happen, there's a website. You have to learn how to read the stuff up, right? It's called something like Reference C++. You can even download it, right? Really good website to read up stuff. But you have to learn how to read this stuff. That's also like a skill. I'm still learning to read this stuff here, right? Sometimes it's better to read stuff like this than YouTube videos, because YouTube videos can be like totally wrong, right? And this is good, right? In the beginning, I was like I'm gonna read and watch a YouTube video instead of reading stuff like this, because it's like sometimes hard to understand. If that makes sense. So for V2, the compiler will determine at compile time that a division with a double operand and an integer operand will produce a double result. Remember that arithmetic operator must have operands of matching types. So in this case, the integer operand gets converted to a double and the floating point division is performed. So double is the type of this expression. The compiler can use the type of an expression to determine whether an expression is valid in a given context. For example, okay, we have this, blah, 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 blah. Okay, yeah, we have the integer x here. And then we have that. Okay, good. This is fine. Then we have our main here. Then we say print, and then we say foo, right? Okay, got it. This is not going to work, right? Of course. Arrow print was expecting an integer argument. We try to pass in a string literal. Okay, in the above program, the print integer function is expecting an integer parameter. However, the type of the expression we are passing in the string literal foo does not match, and no conversion can be found. So compiler error results. Note that the type of an expression must be determinable at compile time. Otherwise, type checking and type deduction wouldn't work. However, the value of the expression may be determined at either compile time. If the expression is const expr or runtime, if the expression is not const expr. The value categories of an expression. Now consider the following program. Okay, we have our integer, we have integer x, we're gonna initialize the x with 0. Then we have x equal 5, and then that's valid, right? Because it's an integer. This is an integer, and so this is valid. We can do this. We can assign 5 to x. 5 is equal x, error. Cannot assign value of x to a literal value of 5. Not possible, right? Return 0. That makes sense. One of these assignment statement is valid. Assign value 5 to variable x, and one is not. What would it mean to assign the value of x to a literal value 5? So how does the compiler know which expression can legally appear on either side of the assignment statement? Okay. The answer lies in the second priority of the expression, the value categories. The value categories of an expression or a sub-expression indicates whether an expression is resolved to a value, a function, or an object of some kind. This is interesting. I think I overread it the last time. The answer lies in the second priority. So I like these questions, right? So how does the compiler knows which expression can legally appear on either side of this? It's defined this way, right? The value categories of an expression or a sub-expression. Am I getting confused here? Indicates whether the expression resolved to a value, a function, or an object of some kind. Okay, I'm keep reading. Sometimes stuff is getting clear if I'm keep reading, you know. Prior to C++11, there were only 2 possible value categories, L values and R values. Or don't tell me that we have now more. Do we have more now? In C++11, there are additional value categories. Oh my god, 9! Okay, let's go. GL values, PR values, and X values. Were added to support a new feature called move semantics. Oh, yeah. Okay, I have to do this topic also. Oh my god, this is so nice. Author note: in this lesson, we will stick to the pre-C++11 view of value categories. This makes for a gentler introduction to value categories and is all that we need for the moment. We will cover move semantics and the additional 3 values categories in the future chapter. Okay, L values and R values expressions. So guys, if you're new here right now, at the moment, we just redoing this topic at the moment because we did was it yesterday? We did unary, right? Overloading stuff, right? So and then we ended up here with R and L values, and I want to reread it because it's, I think, like 7 weeks ago I did this topic, or 8. An L value, pronounced L value, short for left value, or locator value. What is a locator value? This is interesting. What do you mean? They make sense when you see examples. Okay. Locator values. Shift. Okay. Do what's CO3 F001, right? You just hear where I started this journey, right? Since I started this journey. For me, it's interesting to come back to a topic if you're getting more knowledge after time, because you're figuring out that you missed just some stuff before, you just jumped some topics. It's really interesting just to come back to a topic and reread it. Elevate and others are misnomers. Okay, dude. Don't tell me. Really? It's the same with vectors, or what do you mean? You will see. Historically, it's left-hand side value. Yeah, I know. Versus right-hand side value. Then thinking about assignment. I still notice. The term... I know. Yeah, I know. Yeah, okay, got it. The term identity is used by the C++ standard, but it's not well defined. An entity such as an object or function. What is like entity? I mean, for me, it's also like kind of like in language barrier, right? But I think maybe it's make even sense to learn programming completely in English, because most stuff is in English, to be fair. It's entity is like object. Oh, okay. So is it better if I have a class and if I'm creating an object, to say I'm creating an entity? What is the correct sounding then? If I'm doing like I have a class test, and then I say test, and then and I just generate test 1. Am I gonna say I'm generating an entity? No, right? I'm gonna create an object, correct? To use the word because object has existing meaning in the language. So if I'm creating an object, so it is existing, or what? Okay, then I'm gonna, if I have a class and I'm creating a new object, I'm creating this new object, right? Because it's existing, right? When I'm going to use entity then? Yeah, it's no problem. I'm going to read it. Just listen to my great English. Not formal definition. Okay, so okay. Such an object or function that has an entity can be differentiated from other similar entities. Okay, good. Typically by comparing the addresses of the entity. Entities with entities. Wait. Wait. Entities. What? Wait. This is interesting though. Identities. Entities with identities. This is.
Identity.
Or it's like identities. Entities. Wait. That's like entities with identities can be accessed via an identifier, reference, or pointer, and typically have a lifetime longer than a single expression or statement. So, yeah, okay, this is interesting. So we have this, blah, 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 then... I remember back then we had like... This is a name. Okay, perfect. So we have the 5, and then, yeah, we initialize the x with 5, and then we say we initialize the epsilon with... Oh, this is interesting. So x is an Lvalue expression, left-hand side, right? In the above program, the expression x is an Lvalue expression as it evaluates the variable x, which has an identifier, correct? So that means x have to have at least a lifetime to do this initialization, right? Otherwise, we would have like a problem. Since the introduction of a constants into the language, Lvalues comes in two subtypes. A modifiable Lvalue is an Lvalue whose value can be modified. A non-modifiable Lvalue is an Lvalue whose value can't be modified. It makes sense. A non-modifiable Lvalue is an Lvalue whose value can't be modified. Because the Lvalue is const or const expr. Interesting. This is really it's really cool to do relearning thing, right? 5 does not have an entity. Yeah, that makes sense. Entity was like yeah, it makes sense. Yeah, completely. I know. So we can't change the 5, right? No, I mean we can, but I know what we had like before, like 8-9 months weeks before we had like a discussion about this topic. So value can't be modified because Lvalue is constant const expr. Then we have the integer x, we're gonna initialize with 0. Then we have const double d, we initialize with 0. Is it correct if I'm saying it's gonna get initialized with 0? Yeah, right, it is. 5 is an eternal or pure. PR value is pure. That's interesting. Okay. So that's a pure, but why then just not mentioning it then here, you know? It would make absolutely sense to say it's pure. It would be a really nice example. Okay, by the way, this is a pure R value. So, integer x, const double. They call it where? Where's the PR value? Did they call it like this? Where? I can't find it. Okay, we are initialize it with 0 here, also with 0. Then we say integer y is x. Okay. X is a modifiable Lvalue expression. Yeah, we can modify the x. Correct. Const double e is d. Because of const we can't. Yeah, it's also possible, right? D is a non-modifier Lvalue expression, so we can't modify the d here. We can read it, but we can't modify the d. Here we could modify it. So an R value, pronounced an R value, short for right value, and sometimes written as an R value, is an expression that is not an L value. That makes sense, huh? Makes sense, yeah. That makes sense that this is an L value and the other is R value. It makes sense. So R value expression evaluates to a value. Commonly seen R values includes literal except C-style string literals. Are you gonna creating games? Are you? Because I'm learning C++ or what? I don't think so. I don't know. I'm just here to learn C++. CO3 FCO01. Is it maybe? I don't know. If it's not, is it not a overkill to say I'm learning C++ because I want to start to make games? Like, I mean, you first have to learn the basics of C++, right? Or is it good to jump in or like really early? I'm interested in games, but I'm, first I have to learn it, like at least the basics. And then you can do stuff. But to be honest, I'm a little bit more on the business side, to make my life a little bit more easier. This is the juicy thing. creating programs, games is pretty divorced from playing games. True, yeah. I like to play games also, but the thing is, you have a certain amount of time, and for me, it's right now super interesting to do this, right? It helps me with my business sometimes, understanding, give me a deep understanding, but sometimes I also really like to chill and play games. Yeah, I think you're getting a deep understanding. The thing is it good if someone want to just learn something to get like really fast something done, then it's maybe other language better. But if you want to go to get a good understanding what's actually going on, I think C++ is pretty good. Or C, right? Something like yeah, it makes sense. You know, if you like from a business point of view, if you want to have produce something really quickly, maybe C++ is not the best solution. I think in tech, C++ can be really interesting if you like in engineering or whatever, right? Or if you want to make a game or something have to be really fast or whatever, I don't know. Then probably C++ is a pretty good language. I think every language have the cons, the pros and cons. Actually, I checked the UDP protocol, the new one for streaming, and it was really interesting. And I was like, maybe someone have already a solution, and there was one solution already in C++ for the server side application. They did it in C++, and the client side they did in Python. I'm completely fine with that, right? So server side you need the performance, and then the client side you not need it. So it's fine to do it in Python because you can just do it really quickly. So this is completely legit solution. And Rvalue pronounce Rvalue. Yeah, and how you said it already is U3 FCU1. You're getting this understanding if you're reading code from another language and someone said, oh, they're doing it this way, and then you know, they're doing it this way because of this and this in C++ or whatever, you know? And I say, oh, that's not that unsmart, you know? It's pretty cool. So an R value, right-hand side value, pronounced an R value short for right value and is sometimes written as R value, is an expression that is not an L value. R value's expression evaluates to a value. Commonly seen R values included literal, except C-style strings literal, which are L values, and then return values of function and operators that returns by value. R values aren't identifiable, meaning they have to be used immediately. What is this word?
Immediately.
Immediately. Immediately.
Immediately.
Immediately. I have a problem to pronounce this correctly.
Immediately.
Immediately. It's like immediately. I don't know how to pronounce it correctly.
Immediately.
Immediately. Immediately.
Immediately.
Immediately. It sounds weird if I'm saying that. And only exists within the scope of the expression in immediately. Immediately. How to pronounce this correctly? Immediately.
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 I don't know. But it's like
Immediately.
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 Immediately. Immediately. I don't know. It's like I'm missing something apart, you know, if I'm saying that. Immediately. This is like I have to learn it off stream. You have to live for now with this immediately. Oh, that's so hard. Immediately. immediately. So, and only exists within the scope of the expression in which they are used. Okay, done. Okay, let's keep going. So we have the return 5. Okay, interesting. Okay, return 5. Okay, it's fine. So we have our this is our function. This is our main. Then we initialize it with 5. 5 is an Rvalue expression. Yeah, 5 is an Rvalue, of course. Then we have const double d 1.2. It's also is an Rvalue expression, correct? And then we have integer y initialized with x, and this time is a left-hand side. X is a modifiable Lvalue expression. It's modifiable because it's not const. Then we have const double e, and then we have d. And then because it's defined this way, d is a non-modifiable Lvalue expression. Yeah, makes sense because we defined it here. Yeah, okay, perfect, got it. One question: what is gonna happen if I have my const double d here, something like that, right? And if I have only double ed, how is C++ handling that? I think it would be really bad programming. Because why? So no problem, it's a copy. Yeah, I thought also about this. It's a copy. So no problem. Okay. Integer set, return 5. Okay. Initialize this. This is also an... Yeah, of course it's an Rvalue. This is also... Sometimes you have to read something really carefully. Return 5 is an Rvalue expression since the result is returned by value. Okay. Back then, I just overjumped that. But actually, we could have a discussion about this topic, right? Why is this now an Rvalue? I mean, there could be also like an argument, it could be an Lvalue. Yeah, okay, I'm getting it. Okay, here we have something that got initialized, right? The x, correct? And here the function will not get initialized or something, right? So it's returning just the value 5. And that's probably a cake beam. How? That's probably the reason, right? No, it's not the reason. Nice, okay. Mir geht's gut. So what is the reason then? What does it mean? The result is returned by value. What is return 5? That's the question. How the assembly code is gonna look like. It's a function. Okay, I would have a function also. And this function would give me, it's gonna return me 5. And the 5 is an Rvalue. But what is the function then? Oh, no, I'm digging too deep again. So if I'm initializing x, I will have, for example, allocated memory space, correct? For the x. in this x, I will gonna save the 5, right? I'm gonna initialize it with 5. So then I know, okay, x is getting initialized with 5. For the function, I mean, this is a little bit tricky, to be honest. Return 5 is the invocation. Do the easier one, x plus 1. So if I have x plus 1, well, I could do this also with the function, correct? Wow, okay, I have something new. We're gonna check it. This is cool. This is cool. So we have this here, right? Can I not say it's also working, correct? Wait, why I'm not getting something returned? Program returns 0. Where I can get the... okay. Okay, wait. I'm gonna add it. Give me a second. See out, and then we say, okay, return 5. Boom, boom. And let's see what we're getting. IO stream not implemented. Okay, it's getting this. Include IO stream. So now we should have it. Perfect, and we're getting 5. What is going to happen if we have this? This is also working. So, and if I have the same thing here, if I have, for example, x plus 1, this is also working, right? So, okay, but what is x plus 1? A good question. A mixed up value. So think of it like this. Why does reference plus 1 make no sense? Yeah, that make absolutely no sense. Because we're just referencing to the memory area where the value of x is stored, right? So x plus 1 is not... that make absolutely no sense. But because we have no space for x plus 1. We have only x. We have the memory space got allocated for x. The question, what is gonna happen for like a function? How does this is allocated, right? How a function, I mean, you can check it, right? How it's gonna look. So return, then we're gonna just call it, right? So how can check assembler code? How is this possible again? I want to see the code in a sample. Assembly, is it a sample or assembly, right? Assembly, right?
assembly.
Yeah. Where change to compiler. How can change the compiler here? Here, this here? To which one? Executor to compiler. How can change this? No. No. Do add. Yeah, and then? The plus button? Source editor, different view, tree. What should I do? Okay, got it. Okay. So we have this. It's just a call, right? Then we have the main return 5. Yeah, we not need the address for there, right? Let's initialize something. Okay. Here we allocating something, right? Is allocating the correct word for that? But if I have a function, we're gonna jump to the function, right? It is like, we have this, do this, do this, do this, and then do the jump to the function, right? But the function itself, it has to be also, it needs an address, correct? Because it needs an address where the function is, or am I wrong? I'm just trying to understand what's going on. The function does have an address. Reference return 5. So we have then the address to this thingy here, or what? So if we're calling the function, we're ending up to always going directly to the return. Is it like that? No, don't even look at the body. Just look at the prototype. Which prototype? Oh man, I'm digging too deep again. What I'm not understanding here. Here we're allocating memory space for sure. That's what we're doing here for this one. So for the X, and we initialize it with 1. So here it is stored. Correct? Ah. We just referencing to the 5 directly? Because we're jumping to the function, it's gonna reference directly to the 5, and the 5 is my Rvalue, right? No? Oh man. Oh, I'm getting more and more confused. Line 4 has nothing to do with it. Okay, nice. Okay, then. When line 10 calls. Okay, wait, let's go back there. When line 10 calls. Maybe I should put this here that you can see it. Wait 1 second, underneath here, so you can see it, right? So when line 10 calls it, right? We're calling it here. Okay. The body wouldn't matter. It call it the same way. That's why you can forward declare function. So we're going here. Line 10. So we das müsste genau here. This have can I not click? It's going here exactly. So on this here have also his has also his own address, right? Okay. What matters here is the return object. Yeah, this is here my return object here. This here. Ah, I think I know what you mean here. We're returning an integer. And the integer is an Rvalue. Correct? I can live with that. Oh, this is so interesting. It doesn't have a name, yeah. True. And here that has a name, right? It's X. It's and an address. This is all changed if you do integer reference return 5. What is then gonna happen? Oh my god, okay, let's try it out. So you said if we're gonna do... oh man, C++ is so cool. But I have one question. How the compiler knows if I allocating here this for the x, that x is actually this here? Because we have here no name, nothing, you know. How is this then line 9? Move RB to RSP. But still we have no X or something. Oh, you mean this? In C++. But how C++, you know, with the compiler? Here we declared it as an X, right? That makes sense for me. But if it's use later the compiler and compile it to the assembly code. Okay, got it. Yeah, okay, it makes sense. Okay, yeah, okay, got it. It's a compiler thing. Okay, yeah. It's clear now. So now we're doing the other thing. Oh, I like these rabbit holes, right? Integer, you said like, what's the integer and then return. Oh, now it's getting interesting. Return. What do you say? Now we have a... Okay, you want... What one do you want to return 5? You want to have it something like this? Yeah. And then return 5. You want to have it like this. Compiler failed to do this. Yeah, good. This has to be now an... this is now an... what is it? I'm already confused. This is an L value, right? No, that's an R value. This is an R value. And it has to be an L value. Non-const L value reference to a type integer cannot be temporary. So if I gonna do something like integer x equal 5, bam, and putting here then my x, this is gonna... Reference to stack memory associated with local variable x returns. I mean, it's working, right? No, we're gonna do it the other way. Wait, we will say integer x here, right? And then we're gonna say, boop, we want to have an input here. And we say the input will be 5, for example, right? So we have the same error then. Warning reference to a local variable x returns local address. Warning reference to stack memory association with parameter x return stack address. Huh? Why is this so bad now? So what you're gonna do is we return 1 second. 1 second. So, okay. This is in return 5, so I mean, this looks normal. So we might make it not in reference, we're doing 5 here. And then we say huh? Huh? What? Ah. My mistake, sorry. Okay, yeah, okay, interesting. Could do something also like okay. That makes sense. 5 integer in and 5 back. We could do a reference. Mm-hmm. What is gonna happen? So we have this here. Getting back to 5. If you have the reference. Uh-huh. I'm a little bit confused at the moment. Checking assembler. Ah, okay. I think I got it. Do we have here a copy? We have, right? CO3F, CO1, are you still here? Mm-hmm. I have to play quick again with references. If I have something, for example, I say I'm initializing just x, and then we're gonna say, okay, I wanna have, we're gonna initialize it right away. 1 second. With 5. And then we wanna print out, for example, the reference of x. What I'm gonna get, the address, correct? Yeah. Oh, wait a second. Oh, this is also a pitfall, by the way, in C++. You can have this as a reference. And reference is, you can have an address operator, or how it called. This can has two meanings. So it can be the address operator. It can be a reference, right? That's not the same. Really, really important. Let's read it up again before I say something wrong. Creating a reference in C++. Think of a variable name as a label. We're not gonna. You can think of a reference as a second label attached that a memory location. Therefore, you can access the content. It's the same. It's working like a pointer, but you not have to write that much. You have dereferentiated. And this stuff I remember very well, either the royal name of the reference. So if this, and then we're gonna do this, is E. Read the reference in this declaration as reference. Thus read the first declaration as R. Is an integer reference. Initialize to E and read the second declaration as S. So it's double reference initialized to D. Following example make us reference on integer and double. Okay. E is 5 and R is well. This is interesting. I want to check this. Sometimes it's really good to relearn stuff. So let's check. Yeah, that makes sense. Value of the reference is 5. Yeah. C++ dereference. So exactly type pointer. Declare a pointer variable called PTR and a pointer of type blah, blah, and then we have time PTR and then we have a short adapt this conversion. Oh, okay. For example, okay, declare a pointer variable called IPTR pointing to an integer. Yep. I don't know if this is correct even. It contains an address. That address holds an integer value. Yeah, this is correct. Declare a double point. This is fine. PR and PR integer. He is an integer. Okay. That's weird. You can do something like this. Oh man. Okay, let's check this here. So we have, for example, integer number equal 88, an integer variable with an Rvalue, and then we have this. We creating the pointer. That's declare a pointer variable called p number pointing to an integer or an it's more an integer pointer. I like it more this way. And then we have this here. This is a not the reference. This is like the address operator here, assigning the address of the variable number to the pointer number. Yeah. And declare another int pointer int to address of the variable number. Kann man machen. A pointer that points to another pointer. What? Yeah. Why not? So in the direction or the dereferencing operator, the indirection operator or dereferencing operator on the pointer, and the returns the value stored. That's actually what the reference is doing then, right? So we have this process then already. So a reference is something like we have this already existing, and then we're doing that. And this. So we declare and assign the address of a variable number to the pointer, blah, blah, blah. Then we have the address and print the value pointed to by the pointer, which is an integer 88. Yeah. I'm thinking I'm a little bit confused at the moment. I'm gonna fix the problem. So we have this. Is it then a reference? Yeah, it is, right? The problem what I have at the moment, I don't know if I'm doing that. Well, this is an address operator then. It's not a reference, correct? It's the address. It's returning the address. Oh, I missed chat, by the way. Sorry, guys. Oh, sorry. It's the same problem. Sorry, I missed chat. Okay. So this is a reference here. Or what? Okay, when I know it's the address operator, when it's a reference. Okay, so integer has no time, so it's a type, so it's a reference. And if it has a type, it is an address operator then. Well, the x is not the type. Oh, no, sorry. What it's the other way around. So the integer has a type, so then it's a reference. Okay. Okay. So if I have, the case, if I'm gonna say return 5x. Oh no, we're gonna say 5. We say this is an integer x, and then we have here an x, right? If you have this one, it is giving back, it's returning what is this returning then? Wait, this should not work if I have it like this. Why am I right now so confused? If I'm doing this, that should be getting, I should get in trouble here. Yeah, I cannot bind a non-const Lvalue reference of a type integer. Yeah, that makes sense. And if I'm doing it like that, and I'm gonna say so here I'm creating a copy, right? With this 5. I'm initializing the x with 5. To x. Do you understand why this is a problem? It's a different problem. X is an L value that can bind to integer reference. The problem is the lifetime. When you return 5, all its variables are dead, so the reference will be dangling. Ah, okay, got it. So if I'm doing this, And then I have to put something. Okay. I'm not trying. Not playing. No matching function for a call to return 5. Oh man. I'm getting even more confused. Holla, wie so heute, heute ist es mal wieder richtig geil. TTS return. Oh, TTS is not working at the moment, right? Isn't it? No. Return 5 is fine. Look at the caller. No. Where's the caller? Line 9. Cannot bind non-const Lvalue reference to type integer reference to an R value of type integer. Also, always coaching here. It's funny, right? Wait, we have to have a discussion quick. So references are like a pointer, right? Without their own address. So I can't have like a reference to a reference or something. You know what I mean? Not like a pointer to a pointer. And what the reference is doing, we're gonna dereference. How it called? What was the name? Dereferentiate. Was it like this? Dereferencing, right? Do int x return x, wait, return 5x. What should return 5? What should I do? We want to have this. X is equal 5. Line 9 at the caller. Ah, okay. And this is so frustrating. Sorry, mate. Return 5x. Ah, okay, I know what you want to do. You want to do something like x is 5. Yeah, I got this. And then you have this here, right? And everything is fine. So we have the reference to the x. So we have the address, right? So it has the address. So what we have here is then, wait, am I understanding this correctly, or how references are working? Because I will have the reference to x, right? So I have a reference that's not pointing, but it stores the address of x, correct? Is it painting time, guys? It's painting time, right? It's paint. Are you ready? Let's do it quick. 1 second. So, is it not like I have my reference and then I have my x5 and then I have here my address ADR, right? And then here I have my ref, correct? And it's pointing to this reference, correct? It's referred to X, correct? No? Maybe I still have a problem to understand how reference is working after I don't know 2 months of C++. No, it's 3 months. But I thought a reference is the same than a pointer, but it has not his own address. Oh, dude. Wait. The last pile. For me, a reference is working in the same way than a pointer, but it has not his own address. So, back to this beginning topic: reference versus pointer. C++. Images. No. I need a good example. Ah, this one was it, right? So reference E. Then I have my RE. To this address. I'm a little bit confused because if you have now here this PI, right? So if I'm gonna call PI with C out, I'm gonna get the address, correct? So I have to dereference, do this dereferencing stuff to get the value. Oh. And if I have RE, and if I'm using RE, I not have to do this dereferencing stuff, because if I'm typing RE, it will be the value already. Or am I wrong right now? I mean, I can try it out. Yeah, I think the diagram is wrong, right? Just because this makes no sense. Here it has to be a reference thingy, right? To the address. Oh man, there's so much bad content. It's insane. So many pitfalls. Is this maybe better? Yeah, 1 second. I want to check. So, types of versus reference types. So we have reference here, string name Humpy, okay. Reference location, and it's pointing towards Humpty then, because we stored this. So it's doing this. Can we say that the reference is do this dereferencing stuff automatically compared to a pointer? You know what I mean? It's a reference stored the address, right? I mean, I can try it out. Let's do it. Let's do it. Okay. So if I have, for example, we have here a reference. And then we're gonna say, and then if I'm just gonna say, or it's, what, yeah, exactly. So here can I say then just here I'm creating a reference, right? And in the reference, the address E will get stored, correct? Can I say I'm creating a reference from type integer, and it's gonna store the address of E? And if I'm calling the reference X, it uses the address of E and do the dereferencing by automatically compared to a pointer. So X and E are the same thing. They are. Oh, maybe I should check the compiler code. You're correct. Okay. We're doing it on this side. So. Okay, makes sense. Yeah, but we're creating something here. And we're getting the address from here. Okay, I don't know what qword is doing to be honest. I have to check. Wait, I knew what it is doing. Wait 1 second. Too many windows. What is the difference about D word and Q word? But we're creating a reference, right? What? No, we're creating actually a pointer. I mean, 32 versus 64. I mean, this is 8. It is a pointer, correct? I mean, we can make it even different, more interesting. We could say, make something like this, and we're gonna call it PTR, and then we're gonna say please to E, and now we're gonna check what will be the difference here. Hey, why is this not working? Ah, okay. Had this? Wait a second. Ah, my mistake. Yeah, of course it's not gonna work. Huh. So, it's now I'm even more confused, boys. It is the same, you know. It is. Can we say like a reference is like an abstraction that under the hood it's working like pointers, but it's dereferencing automatically, so you not have to do like integer pointer blah blah blah, and then because if you're doing something like this now, for example PTR, you gonna get wait, compiler. You're gonna get like the address, so you have to dereference it, and you're gonna do it like this, and then you're getting the value instead, right? You're getting the 1. So, and if you're doing the same example with the reference, right? And you're gonna say, okay, do X, right? It's doing already the dereferencing thing, right? It's can we not say it like this? X won't have an address, but they happen to give it 1. No, I'm confused. You want to have this example? 1 second. So you want to have this example. We have our PTR. This is this one. And then we do this. If you're doing that, this is still the address operator, right? Then we're getting the address of the pointer instead. Correct? Wait, you're gonna say, no, that's not the same, right? If you say, you say X is equal E, okay, let's. So if I'm doing the, but, I'm getting your point. I'm understanding your point. So if you have this like that. Oh, fuck me. I mean, this x is... So you want to say the compiler, it's just like it knows x is equal 1. Is it working like that? So actually it's not getting initialized in a way. We're gonna do this here. But we're creating here something, you see that? If I'm doing that, we have only this here, 4, right? And I have this here. Ah, you mean this here is optimized or what? You mean this here is optimized? You're not really wrong, but the difference is subtle. What does subtle mean? Too many things opened. But I think I get your point. I think you get the point. The point is the compiler is interpret how it called
interpret,
the compiler is going to interpret it, right? It's not actually existing. We have an address operator, but the reference operator is like it's getting interpret, correct? Can we say it like that? Because we not have it in C. Integer e is equal 1, integer x is equal 1. Which one is t? Is t he variable? What t? You mean e, right? Yeah, pointers can be changed. Makes sense. The pointer can be changed because the pointer has his own address. So that's the thing about references. Why it's better to use references, because you can't change them. Okay. The variable. The variable will be the e, right? Now the question is the x actually the reference? I mean, the x is a reference, but you said x is equal e. E refers to a variable on the stack. Yeah, correct. So if you have this example, X refer to an... So X refers to an Lvalue that refers to a variable on the stack. Can we say it like that? Oh, you don't know what I'm saying. Okay, I just said, for example, with your example, right? Or like the example of here. If you have this here, so this is the case, yeah? So X, wait 1 second, I have to read the chat again. Where is this chat message? 1 second. So, okay, again. X refers to E. E is an Lvalue, an Lvalue, and E refers to E. To 1, sorry. To 1. My mistake. Can you say it like that? So E is the name of the memory in the stack. Okay. But I mean, I need from my point of view or understanding, if I'm doing it, I will have like a routing, right? So I will jump to this address. From this, I jump to this address, and then finally I'm gonna jump in assembly to this address to get the value. Correct? What? Oh my god! Really? Wait. All right. All right. It just happened to be translated this way. There has to be. Okay, there can be some optimization. Okay, I got it. Turn on OptS2. How can turn it on? Can you just? In the compiler option. Where is the compiler option? More template. Here. I got it. Okay, let's see. O2. Okay. Minus O2, I did it. XOR EX equal EX. Okay, then it's... what? Wait. It's the same. No, it makes no sense. Okay, why it is like that? Oh, I get it. So the question is, if I'm doing this minus O2, is it like more optimization stuff? Yeah, of course the program doing the same thing. I know, but I just want to... So it's... Okay, okay. That makes sense. That makes sense. But normally you can say, if you have this one, you're getting it... You're creating something... I get it. But here you're doing allocating something, right? You're creating another pointer, -8. Even if it's the same. I'm a little bit confused if you even looking this one, why we have here -12, right? If you have it like this, it's only -4. That makes sense because it is an integer. But why I need more space if I'm doing the reference here? Why I have -12 then? Why it needs even more space? This is weird. This, okay. But this is weird. But I can say, right, that it's not completely incorrect if I'm saying that the reference has not his own address compared to a pointer, so it can't be changed, and it's doing this dereferencing stuff automatically, right? For me, it's not weird it has his own address, but it can be optimized, right? It's from a logic point of view, it makes sense. From the optimization, it makes no sense because it's the same. Optimization point of view. It's putting the address in array, which it totally doesn't have to do. This is gets into details of code generating though. Can we say pointers are more like
imaginary,
in a way, if you compare it with pointers? Yeah, pointers. No, I said if you compare it with pointers, pointers are actually objects. Yeah. But I would say like the reference is like imaginary in a way. It's like a type def. Yeah, okay. Yeah, but the full, I mean, it is, yeah, I get it. But if you have like this type dev under the hood, it's probably working with pointers. You get my point, right? That's it. It is gonna do like the dereferencing stuff by his own, like automatically. So you not have to do it. And it will not have his own address, so you can manipulate it in a way and getting a segfault that easy. Yeah, I think this is the full point. Yeah. With that, I can live. With that, I can live. I can live. Wow. Okay, this is funny, right? Yeah, I mean, if you compare it like this, it's the same shit. Sorry if I'm saying that. Sorry, guys. If you compare like vectors, what is the different about the vector? What is the different about an array? Correct? It's like they are just a little bit defined differently, in a different way. Oh man. Okay, let's finish this. Oh, not finished it, even close. Okay. Keep going. I have to check my mobile phone. Give me a sec. Okay. How much is it? Gonna finish this quick. So okay, let's go. An R value, pronounced R value, short for right value, and sometimes written as an R value, is an expression that is not an L value. R value is an expression evaluates to a value. In value. Commonly seen R values included literal except C-style string literals, which are L values, and then return value of a function and operators that return by value. R values aren't identifiable, meaning they have to be used immediately, and only exist within the scope of the expression in which they are used. Okay, now we have return 5. This was the same what before, right? So, yeah. So for this, 5 is an R value expression. True, I got this. It's an R value expression. Yeah, then we had like this question why this is an R value. Because of the reference. Yeah, okay, got it. It refers to the 5. This is like, still, it's kind of special, right? If you think about this. Oh man, this is special. There's no reference. In this case, there's no reference. Okay, yeah, true. So we have this, but still, why it's an R value? Because it's an unnamed object. Yeah, but it's for me weird because the class called return 5. You know what I mean? You could say that. Okay, so functions are no objects. Okay, got it. Finished. It's defined this way. Function are no object. So If you don't bind it to something, you'll never be able to refer it to it again. Okay. Makes sense. Return file, how you're gonna get the result of last statement. How you gonna get the result of the last statement? Because it's getting destroyed. Now I'm getting it. It's a different if you're calling something and you're returning it, but you know it's gone, right? It's just gone. I got it. You're losing the state, right? You're losing the first call. You never can reference to the first call again. It's temporary. Oh, perfect. Thanks a lot, man. So now we have the integer w x plus 1. X plus 1 is an Rvalue expression. Yeah. Makes sense. It's the same thing here, right? Doesn't have a name. Then we have q static cast integer d. Static cast into a d. The result of the static cast d to an integer is an Rvalue expression. Doesn't have a name. Whew. Okay, you might wonder why return 5 x plus 1 and static cast integer d are Rvalues. No. The answer is because these expressions produce temporary values that are not... Okay, this is also a really good sentence here. That are not identifiable objects. Key inside. Lvalue expression evaluates to an identifiable object. That's a nice statement. Rvalue's expression evaluates to a value. To a value. Sorry. Now we can now we can answer the question about why x equal 5 is valid, but 5 equal x is not. Yeah, 5 is not an object. An assignment operation requires the left operand of the assignment to be a modifiable Lvalue expression. Yeah, it's not modifiable. That was the reason. Yeah, okay, makes sense. And the right operand to be an Rvalue expression. The letter assignment 5 equals x fails because the left operand expression 5 isn't an Lvalue. Correct. So we'd have to check if we got everything. We can break these rules. No. Not breaking rules today. We broke already too many rules here. Integer main integer x will get initialized with 5. Assignment requires the left operand to be a modifiable Lvalue expression and the right operand to be an Rvalue expression. So then we have x is equal 5. This is value because x is a modifiable Lvalue expression and 5 is an Rvalue expression. It's defined this way. So then we have 5 equal x, arrow 5 is an Rvalue expression and x is a modifiable Lvalue expression, return 5. Perfect. Related content. Really? Related content. Okay. A full list of Lvalues and Rvalues expression can be found here. In C++ 11, Rvalues are broken into two subtypes, PR values and X values. So the R values we are talking about here are the sum of both of those categories. Tip: if you're not sure whether an expression is an L value or R value, try taking its address using operator. Wait, this is the address operator, which requires its operand to be an L value. Makes sense. If the address expression compiles, expression must be an L value. Makes sense. It has his own address. And here you can see compile x is an L value expression because we're getting an address. And here doesn't compile 5 is an R value expression. Doesn't compile foo is an R value expression. Oh, cool. Okay, keep going. Key inside. A C-style string literal is an L value because C-style strings, which are C-style arrays, decay to a pointer. A C-style string literal is an L-value because C-style string, which are C-style arrays, decay to a pointer. The decay process only works if the array is an L-value, and thus has an address that can be stored in the pointer. C++ inherit? Is it inherit?
Inherited.
Inherited. Yeah, it's just relearning today. Beaver logic. Just relearning the topic again. Inherited. This is backwards compatible. We covered array decay in lesson 17.8. I should redo this also. L values or maybe I skipped this topic even. L values to R values conversion. Let's take a look at this example again. So we have integer x, we're gonna initialize it with 5, and then we say integer y is x. X is an L value expression. Yeah, makes sense. Return 5. If x is an L value expression that evaluates to variable x, then how does y end up with value 5? The answer is that the L value expression will implicitly convert it to R values. Okay. In context where an R value is expected but an L value is provided, the initializer for an integer variable is expected to be an R value expression. This L value expression x undergoes an L value to R value conversion, which evaluates to value 5, which is then used to initialize y. We said above that the assignment operator expected the right operand to be an R value expression. So why does code like this work? So this is okay. Epsilon is a modifiable L value, not an R value, but this is legal. Probably a conversion again. In this case, y. It's y. In this case, y is an L value expression, but it undergoes an L value to R value conversion, which evaluates to the value of y, which is then assigned to x. Now consider this example. In integer x gets initialized with 2, then we say x is equal x plus 1. And it's the same. In this statement, the variable x is being used in two different contexts. On the left side of the assignment operator, x is an L value expression that evaluates to variable x. On the right side of the assignment operator, x plus 1 is an R value expression that evaluates to a value 3. Now that we covered L values, we can get to our first compound type, the L value reference key inside. A rule of thumb to identify L values and R values expressions. L values expressions are those that evaluates to variable or other identifiable objects that persist beyond the end of the expression. R values expressions are those that evaluates to a literal or values returned by function operators that are discarded at the end of the expression. Perfect. I think that's it for today. Tomorrow I'm not going to stream. I will be back on Tuesday. And thanks a lot for supporting me today, helping me out here with this topic. And you can find the VOD on YouTube if you want to. If you want... we got here something. I don't know if I should open this. I really don't know. Okay, let's see. Return A. That's Okay, forward declaration. You broke the rule, right? CO3 F001. Can you maybe then explain? Can you then explain why it's working? Return A is a function. That's a good. But in this case, return A is an object, correct? Yeah. Okay. Then we're gonna. I don't know. We're gonna do this topic next time. X value. I'm gonna save it in my Discord quick. Yeah. I think this will be. So C++, where is it? Programming stuff. C++. Boom. Code example. Topic called X value, right? Can I call it just X value example? Because I just want to post it on Discord. Yeah, okay, perfect. Then I will just post it X value example. We're gonna do it next time then. So, yeah, wait, I'm gonna. So, guys, I wish you then and girls a nice evening. Thanks a lot for hanging out with me, helping me to get better in C++. And it was, again, a lot of fun today. I'm out. I wish you a nice weekend. See you probably on Tuesday.